Look up. Right now, go ahead. Out there, in the vast, dark expanse, a drama is unfolding. It's a silent cosmic play that's been running for billions of years. And on September 7th, 2025, we get a front row seat to one of its most spectacular acts. The Earth, the Moon, and the Sun are aligning for a breathtaking performance, a total lunar eclipse. This isn't just any eclipse. This is a blood moon, a moment when our closest celestial neighbor will blush a deep, haunting red. It's a reminder that we live on a planet, a sphere moving through space, part of a grand, interconnected system. Forget your daily routine for a night. The universe is calling. This event is more than just a pretty sight. It's a physical demonstration of orbital mechanics, a lesson in optics, and a connection to our own history. For millennia, our ancestors looked up at this same sky with a mixture of awe and fear. They saw omens, gods, and monsters in the reddened moon. Today, we see science. We see the elegant dance of gravity and light. But that doesn't diminish the magic. In fact, understanding the how and why only deepens the wonder. Knowing that you are witnessing the shadow of your own world being cast upon another is a profoundly humbling experience. It's a cosmic perspective shift, delivered right to your backyard. So, mark your calendars. Imagine you're out for a walk on a sunny day. Your body casts a shadow on the ground behind you. It's long, dark, and perfectly mimics your shape. Now let's scale that up. Way up. The Earth, just like your body, casts a shadow in space. It's a colossal cone-shaped shadow stretching almost 1,000,000 miles into the void, always pointing away from the sun. Most of the time, this shadow just points into empty space. But every so often, the moon, on its month-long journey around our planet, happens to wander directly into it. When it does, we get a lunar eclipse. It's as simple and as elegant as that. For this celestial alignment to occur, the geometry has to be just right. We call this alignment syzygy, a great word to drop at your eclipse party. It means the sun, earth, moon are lined up in a nearly perfect straight line. You might wonder why we don't get a lunar eclipse every month during the full moon. The reason is that the moon's orbit is slightly tilted, about 5 degrees, relative to Earth's orbit around the sun. Because of this tilt, the full moon usually passes just above Earth's shadow, or just below Earth's shadow. It's only on those special occasions when the full moon crosses Earth's orbital plane at the exact right time that it can pass through the shadow. The Earth's shadow isn't uniform. It has 2 parts. The outer, fainter part is called the penumbra. When the moon first enters this zone, the dimming is so slight you might not even notice it. But the main event is the umbra, the dark inner core of the shadow. This is where the real magic happens. So, if the Earth is completely blocking the sun's light, why doesn't the moon just disappear? Why does it glow with that eerie reddish hue that earns it the name blood moon? The answer lies in our own atmosphere. Think about a sunset or a sunrise here on Earth. The sky turns brilliant shades of red, orange, pink. This happens because as sunlight passes through a large amount of Earth's atmosphere, the air scatters the shorter wavelength blue-violet light, but allows the longer wavelength red-orange light to pass through more easily. The moon is about to experience this same effect. During a total lunar eclipse, you are essentially seeing all of the sunrises, sunsets on Earth happening at once, projected onto the lunar surface. As sunlight grazes the edge of our planet, it passes through our atmosphere. This blanket of air acts like a giant lens, bending or refracting the light. As it does this, it filters out most of the blue light. What's left is the reddish part of the spectrum, which continues on its journey through space. This faint reddish light is what ever so gently illuminates the moon, bathing it in a coppery glow while it sits in our planet's shadow. The exact color and brightness of the eclipsed moon can tell us a lot about the state of Earth's atmosphere at that very moment. If the moon appears a bright coppery orange, it means Earth's atmosphere is relatively clean and transparent along the edge or limb of the planet. However, if the moon looks a dark brick red or is almost invisible, it suggests the atmosphere is filled with more clouds. Long before we understood the science, the sudden reddening and dimming of the moon was a source of profound terror and fascination. For many ancient cultures, a lunar eclipse was a horrifying omen. The Inca believed a celestial jaguar was attacking and eating the moon. They would shake their spears and make noise to scare it away. In ancient Mesopotamia, astronomy was deeply intertwined with astrology. A lunar eclipse was thought to be a direct assault on their king. They would even install a temporary proxy king, while the real king went into hiding until the danger passed. In Hindu mythology, the demon Rahu is said to periodically swallow the moon. Rahu tried to steal the nectar of immortality but was decapitated by Vishnu. His disembodied head, still immortal, flies through the sky, seeking revenge by consuming the sun and moon. In many cultures, the response was similar. Make noise. People would bang pots and pans, shout play drums, believing the commotion would frighten away whatever demon was devouring the moon. And since the eclipse always ended, it seemed to work every time. The Batamaliba people in Togo and Benin have a myth that an eclipse is the sun and moon fighting. They see it as a time for the community to come together and encourage the celestial bodies to resolve their conflict, using it as a moment to settle old feuds and grievances on Earth. The total lunar eclipse of September 7, 2025, will be a truly global event, visible to billions across the world: Europe, Africa, Asia, Australia, the Americas. For those lucky enough to be in the right place, the entire spectacle unfolds over several hours. The period of totality will last 1 hour and 22 minutes. Prime viewing across Europe, prime viewing across Africa, prime viewing in Western Asia, prime viewing along the eastern coast of South America. Observers there will see the eclipse high in the sky during deep night hours. For North America, for South America, the moon will be rising, sometimes already eclipsed, which can create a dramatic selenelion. Penumbral eclipse begins around 1628 Universal Time. Partial eclipse begins at 1727 Universal Time. You'll see a dark bite taken out of the lunar disk. Total eclipse begins at 1831 Universal Time. The moon will remain fully eclipsed for 82 minutes. The moment of greatest eclipse occurs at 1912 Universal Time. Remember to convert these universal times to your local time zone. It's a cosmic appointment, and the universe is inviting you to attend. Here's the best news about watching a lunar eclipse: you don't need any special equipment. Unlike a solar eclipse, which requires protective filters, a lunar eclipse is perfectly safe to view with your naked eyes. The moon is simply being dimmed, not becoming dangerously bright. Go outside, find a comfortable spot with a clear view of the sky. Look up, that's it. Bring a chair, bring a blanket, bring hot chocolate. Settle in for the show. Binoculars can transform the view. A telescope goes even further. Binoculars make the moon look three-dimensional. The reddish hues will vary across the surface. You can see the curved edge of Earth's shadow. Through a telescope, you can watch craters and Maria slip into darkness and re-emerge. It becomes a personal exploration. Don't just watch it, experience it. For all the photographers out there, a total lunar eclipse is a bucket list event. It presents a unique and rewarding challenge, blending low-light techniques with celestial portraiture. You don't need a professional observatory's worth of gear to get a great shot. A DSLR or mirrorless camera with manual controls and a telephoto lens, 200 millimeters or longer, will do the trick. The most crucial piece of equipment, however, is a sturdy tripod. The exposures will be several seconds long, and any camera shake will turn your beautiful blood moon into a blurry red streak. A remote shutter release or using your camera's self-timer is also essential to minimize vibration. Setting up your camera correctly is key. Start by switching to full manual mode. This gives you complete control over your aperture shutter speed and ISO. As the eclipse progresses, the moon's brightness will change dramatically, so you can't just set it and forget it. One of the most compelling ways to photograph a lunar eclipse is with a composite time-lapse image. This single picture captures the hours-long celestial dance in a visually stunning narrative that conveys the full majesty of the event. While today we can predict eclipses with pinpoint accuracy, they still offer valuable scientific opportunities. They are not just pretty light shows, they are natural experiments on a cosmic scale. One of the most enduring scientific uses of lunar eclipses is studying the Earth's atmosphere. By analyzing the spectrum of light passing through our atmosphere and onto the moon, scientists can detect the chemical signatures of gases like ozone. Scientists can also look for traces of pollutants and for volcanic ash. The eclipsed moon acts as a distant mirror, reflecting the health of our planet's atmospheric limb back at us for analysis. Lunar eclipses also provide a unique opportunity to study the moon itself. The lunar surface is constantly bombarded by solar radiation and the solar wind. During an eclipse, the Earth blocks this flow, plunging the moon into cold and darkness. This rapid temperature change lets scientists study the thermal properties of the lunar regolith, the dust and broken rock on the surface. By observing how quickly different parts of the moon cool and warm up, we can create detailed maps of surface physical properties from Earth. As early as the 3rd century BCE, the Greek astronomer Aristarchus of Samos made key measurements. He used the size of Earth's shadow during an eclipse to estimate the moon's size and distance. Even today, astronomers use the darkness of a total lunar eclipse to look for things otherwise unseen.